Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the IUPAC rules for naming complexes, students. Okay. Now, rule 1, students. The cations are named first. Rule 1. The cations are named first. Okay, so first you have to write the name of the cation, students. Next, coming to the rule 2. In the coordination entity, students, names are written in the following sequence in the coordination entity. So I'm taking the coordination entity. Coordination entity is nothing but only square bracket part. Understanding? In square bracket part, metal atom and ligands will be there. So that is the coordination entity. In the coordination entity, we have to write the name of the entity. The names are written in the following sequences, students. What are the following sequence? First one is name of the first one is number of ligands. You should write number of ligands. Second one is name of the ligand. Name of ligand. Third one is name of the central atom. Name of central atom. And fourth one is oxidation state of the central atom. Oxidation state. Oxidation state of the central atom. Clear, students? So in the coordination entity, we have to follow this sequence, Nana, in coordination entity. So first we have to write the name of the cation. Next we have to write the anion name. That is the coordination zone. Okay, in our coordination entity. So in the coordination entity, students, that means coordination entity, it may be cation or it may be anion, students. So that's why our neutral also we can take. Understanding? So anionic complexes will be there, cationic complexes will be there, neutral complexes will be there. Understanding, students? So first we have to write the name of the cation. So in coordination entity, how to write the name of the name of the compound, name of the molecules. That this is the sequence. Number of ligands, name of the ligands. Third one is the name of central atom, oxidation state of the central atom. So first I am going to discuss the number of ligands, students. So first one is number of ligands. So when you are writing the number of ligands, students, number of ligands, how to write, students? So numericals, number of ligands indicated by the numerical, students. Suppose 1 2 3 4 5 6. Suppose from I'm taking the from 2, Nana, 2 3 4 5 6 there. Okay, 2 3 4 5 6. Then what prefixes we have to use? Understanding? So what are the prefixes we have to use? Means 2 means di, 2 means di we should use, 3 means tri, next 4 means tetra, penta. Clear? This is hexa. Understanding? And so on. Clear this one? So these prefixes we have to use, students. Understood, Amma? So if suppose in the given coordination compound ligands 2 are there, we have to use the prefix instead of 2 di. 3 there means tri we have to use. Understanding? So this is the number of ligands, students. But in some cases, students, what is happening, students, the name of the ligands containing some ligand, students, they have these prefixes, students, in their names already. Understanding? In their names already they have these prefixes. Then we should not use these prefixes, students. We have to use other prefixes instead of these numbers, students. Those are bis, tris, tetrakis, etc. Understanding, students? Okay, now see, students, the ligands containing any of these prefixes in their names. The ligands containing the ligands containing any of these prefixes, any of these prefixes in their names. Okay, in their names, in their names. Okay, now we have to use other prefixes, students, in their names. Other prefixes, okay, in their names indicated by the prefixes bis. Which one, students? Bis, tris, tetrakis, etc. Bis, tris, tetrakis, etc. That means if suppose two are there, okay, na, two ligands there, then bis, three means tris, four there means tetrakis we have to use. Understanding, amma? So number of ligands. So first we have to write the number of ligands. So number of ligands, when you are writing how many number of ligands are there, we have to use these prefixes. Some other ligands, what they have, students, already in their names these prefixes will be there, so that's why they containing already these prefixes. Then we have to use the other prefixes, students. Are you clear? For example, ene is there, amma. Ene, what is the name? Eno, ethane 1 comma 2, 1 comma 2 diamine. That means already in eno, okay, now already di prefix is there, correct? Are you understanding? Already di is there. That means this ligand is having already in this name, in its name already di prefix is there. So that's why in this case, okay, now we have to use numericals instead of numerical, students. Suppose two ins are there, bis, three ins are there, tris we have to use. Understanding? You should not use di, no, triene you should not use. Are you clear? Like that. Okay, Nama. Next one is till here number of ligands completed. Now we are going to discuss the name of the ligands. Now second one, name of the ligand. Name of ligand. So when you're writing the name of the ligand, students, ligands, first, if names of ligand, students, we have to write in the alphabetical order. No. Okay, now if suppose one ligand is there, just directly we can write, but more than one ligand is present in the coordination zone, you have to follow the alphabetical order. Understanding, students? Alphabetical order. That means names of ligands are names of ligands. Names of ligands are written in the written in alphabetical order. Clear? Alphabetical order we have to follow, students, when you are writing the name of the ligand. Clear? Alphabetical order we should follow. So suppose now I am taking the anionic ligands. Okay, the names of anionic ligands. I'm going to discuss about the anionic ligands, students. See, students, when you are writing the names of anionic ligands, the suffix "-ide", "-ate", clear, and "e" replaced by "o", students. Understanding? When you are writing the names of anionic ligands, understanding anionic ligands nothing but the ligands which have the negative charge, anionic ligands. So suffixes "-ide", "-ate", "e". Okay, these suffixes have to replaced by o, none, replaced by o. See here these are all anionic ligands, students. Okay, anionic ligands, these all are. Now see here, F minus, it is fluoride. What is their names, students? Fluoride, chloride, bromide, iodide, hydroxide, cyanide, oxide, peroxide. This is superoxide, nitrite, nitrate, oxalate, sulfate, acetate, thiosulfate. Clear? So these are general names, Nana. Now coming to here, what are the suffixes they have, students? Here "-ide" is there. "-ide". Clear? Suffixes here, what I told you, the suffix "-ide", "-ate", "ate", "e" replaced by o. Are you understanding? So "-ide". Clear this one? So I here the suffixes "-ide". Here we are taking nana e only, we are taking only e, students. E we are taking, e is replaced by the suffix e. Here e also is there now. Here see here "-ide", "-ate", "ate", "e". Here in these cases only e, students. E is replaced by o, students, replaced by o. That means fluorido, chloride, chlorido. That means e is replaced by o, e is replaced by o, e is replaced by o. Now see here cyanide, cyano, cyanocheme. That means IDE is replaced by which one, students? IDE is replaced by O. Cyano. Okay. And here ide. Here ide is replaced by O. Peroxide. Ide is replaced by O. Are you understanding? Ide is replaced by O. Now see here superoxide is there. Superoxo. That means ide is replaced by O. That means the suffix here nitrite. Nitrite, in nitrite which is replaced, student? Which one? E, only E. Are you clear? So E is replaced by O. Nitrito, nitrate, nitrato. That means E is replaced by O. Oxalate, E is replaced by O. Sulfate, sulfato, E is replaced by O. Acetate, acetato. That means E is replaced. Thiosulfate, E is replaced by O. Are you understanding, students? Okay, Nama. So what are the suffixes are there? I do, I to. Okay. I do, I to, eight, and E is replaced by O, students. Clear this one? This is the names of anionic ligands. So after that, what is the sequence, students? Number of ligands completed, name of the ligand completed. Now third one is name of central atom. So when you are writing the name of the the anionic ligands completed, now we are going to discuss the neutral ligand, students. Understanding? So maximum cationic ligands will not be there, students. Oh, okay. So you are taking only anionic ligands and neutral ligands only you are taking, students. Okay. Anionic and neutral ligands only you are taking, and only one cationic ligand is there, positive ligand, that is NO plus, Nana. Okay, now but we won't get that cationic ligand in names, Nana. So names of anionic ligands completed. Now we are going to discuss the neutral ligands. Names of neutral ligands. Names of neutral ligands. Names of neutral ligands. So when you're writing the names of neutral ligands, students, neutral ligands, here there are some neutral ligands there, students. There are some neutral ligands, H2O, NH3. Okay, I'm writing here H2O, NH3, okay, NO, CO. So and water, H2O is there, means what is the what we have to use, students? Special names we have to take now, no? Aqua. NH3 is there, means amine. Okay, NO is there, means nitrosyl. Okay, nitrosyl. CO is there, means carbonyl. Clear? So these are the special names. We have to use these special names, the special names in the case of neutral ligand, students. Are you clear? So till here name of the ligand completed. In the coordination zone, number of ligands over, and second one is name of the ligand over, third one is name of the central metal atom. So now we are discussing the name of the central metal atom, students. Name of the central metal atom. So when you're writing the name of the central metal atom, students, what you have to take? Name of the central metal atom. So when you're writing the name of the central metal atom, students, if the coordination entity is neutral or positive, if the coordination entity, so if the coordination entity, okay, is neutral or positive, clear, or positive, that is nothing but cation. Okay, is nothing but cation, students. Cationic complex cation, then the name of the metal remains same, students. Okay, then the name of the metal remains same. Understood, Amma? Name of the metal remains same, students. As it is, you have to take. Understood, Amma? This is the first point. Clear? If suppose the coordination entity is negative, students, then the name of the metal is, the name of the central atom is changes, students. That means the name of the central metal atom ends as 8. Okay, now. So if the coordination entity, so the coordination entity is negative, that means anionic complex. Okay, anionic complex, then the name of the metal name, what is happening, students? It is ends as 8. Metal name, what you have to add on a suffix 8 we should add. Are you clear? Suffix, which one we have to take, students? suffix 8 we have to add a metal name. Okay, suffix we should add. So these 2 points you have to remember, students, when you're writing the central metal atom. Understanding none. See, students, if the coordination entity is neutral or it is if it is neutral or positive, students, what I told you, name of the metal remains same. We should not change anything, Nana. Name of the metal as it is will be there. That means, for example, chromium metal is there. Chromium only. Iron only. Manganese only. Are you understanding? What is the name of the metal? As it is, we have to use. But in the second case, coordination entity is negative. Okay, now if suppose the coordination zone is negative, okay, that means anionic complex given, then metal name, to the metal name what we should add, students? 8 we have to add. Understanding 8. Now see this example, students. Titanium, titanium name of the metal. So what we should add, students? Suffix 8. Titanate, that means titanium is converted into titanate. Chromium, chromate. Iron, ferrate. 8 we are adding. 8. Are you understanding? Suffix 8 we have to take, Nana. So cobalt, cobaltate. Copper, cuprate. Zinc, zincate. Are you clear? So that means suffix we are adding 8. Understanding, if the coordination entity is negative, when you're writing the name of the metal, you have to add the suffix 8. Clear? Okay, now, so later I will discuss the example, students. Cationic complexes, anionic complexes, neutral complexes, how to write the name. Then you will get the clear idea. So first you have to follow these rules, students. Understanding, Amma. So till here, name of the central metal atom completed. Name of the central metal. Next, last one is, fourth one is oxidation number of the central metal atom. So what is the fourth one, students? Fourth one, oxidation number. Oxidation number of the central metal atom. So oxidation number of the central metal atom. So this is indicated in Roman number, students. Roman number you have to represent, Nana. And this Roman number also we have to write after the name of the central atom. Understanding, after the name of the central atom in parenthesis. Understanding, it is indicated by, it is indicated in Roman numbers. Okay, Roman numbers just after the name of the central atom. It is indicated Roman numbers, right, just after the name of the central atom in parenthesis. Clear? In parenthesis. Understood, Amma? That means inside the bracket. Parenthesis is nothing but bracket, students. Understood, Amma? Inside the bracket you have to write, Nana. So this is the oxidation number of the central metal atom. Clear this one? So total all rules maximum I discussed is, students. Okay, na? So first what you have to do, students? Oxidation number of the central metal atom all completed. So these are the rules, students. And one more is in case of ambidentate ligands. Ambidentate ligands, what you have to do, students? Ambidentate ligands, 2 donor atoms will be there, more than 1 donor atom. Okay, now. So then donor atom is just what you have to do. It is indicated just after the name of the metal, that I will discuss in the example, students. Okay, so these are the rules you have to follow, students. Then you can easily answer any type of any name of the coordination compound, students. Okay, see here what discussed, students. First, cations are named first. Rule 2, in the coordination entity, here 4 names you are writing. First one is number of ligands, name of the ligand, name of the central atom, oxidation state of the central atom. Number of ligands, in number of ligands 2, 3, 4, 5, 6 are there, means these prefixes we have to add. If suppose some ligands they have already these prefixes in their names, then we have to follow other prefixes. These one, bis, tris, tetragis, etc. Example, ethane also we have to take. Name of the ligand. So in case of name of the ligand, what you have to do, so students, when writing alphabetical order we have to follow. More than one there means. Name of anionic ligand, suffix O you have to add instead of I to A to E. These are all anionic ligands, students. Okay, next one is neutral ligands also we took. These are the neutral ligands. And next one is name of the central metal atom. The name of the central metal atom, when you are writing coordination entity, you have to see it is a neutral or positive as it is name, and if it is negative, then what you have to do, students, 8 we have to add suffix, understanding. And last, oxidation number of the central metal atom, what you have to do, just it is indicated by the Roman numbers, we have to write after the name of the central atom in the parenthesis, that means it is in the bracket, you have to write, students. Okay, I hope you understood this video. If you like this video, please like, share, comment, and subscribe my channel, students. Thank you very much, students.